Hi, welcome to another episode of PSDtv. I'm your host, Alix, and today I've got friend of the show, Mark Adams from CUI. We're going to talk a bit about their software-defined power. Welcome to the show, Mark.
Hey, thanks for the invite.
Well, you talked about the software-defined power the last time we were together, and I understand you've had some advances and developments in the project since, and so I'd like to hear the update.
Yeah, absolutely. Last time we talked about the theory of software-defined power, and particularly the data center that we're addressing with the ice block. And since then, the product has continued to be developed. We're now starting to put it into data centers for first proto units. We're seeing phenomenal results. We have some great results, and being able to show 15 to 25% savings in power, as well as we have a new product that's going to marry along with that, that will allow data centers to use both an A or a B feed for the applications that don't need critical backup.
Very nice, Mark. Now, could you do us a favor? I know you talked about it to the audience before, but since it was a previous presentation, let's do a little bit of a roundup on some of the features.
Yeah, absolutely. So the theory of it is peak shaving. So basically, being able to level out the usage that you're using. So, for example, in this application, what we show is that you have the green part. What you're doing is you're pulling from the battery. So this is part battery bank, rectifier, inverter. So when you go above the usage, instead of pulling from the grid, what you're doing is you're pulling from the battery. When you go below that, then you're charging the battery. So you're keeping within this envelope of the grid usage, and when you need it, it's there, and you can pull from the battery rather than paying for the grid.
And that brings a lot of advantages beyond just simple energy savings, I would imagine.
Absolutely. I mean, it provides. It can also, in the further generations, it'll provide an actual UPS function. So the capex to put this in, the opex of it. Data centers. What it also does is allows you to run a rack with less power supplies, because this can take that buffer rather than putting in additional power supplies. Instead of power supplies, you can put more servers, and that's one of the things with the data centers is they're looking for more compute power, not more power supplies.
Well, and you're absolutely right there, Mark, because when you think about it, every little device, people think, oh, it's just a little IoT device, but that represents like a watt of power in some server somewhere.
Absolutely. The Internet of Things is everywhere here, and the infrastructure to support that, there's a lot of stress on that infrastructure right now, and you have 5G soon to follow that. So being able to get the data in, people want their data sooner, then you have to save it, you have to back it up, the criticality of the data, so all of that put there together, data centers can't grow fast enough. So this enables them to optimize the footprint that they have, as well as optimize the new footprints that they're developing.
Very nice. So this is actually, you can retrofit this easily into a existing system.
Absolutely, yeah.
Very nice. Well, because some of the newer technologies being proposed are complete retrofit, not retrofits. You're going to have to do a lot of things to the facility. So I think this is a very good solution because it allows the facility to minimal invasion.
Yeah, absolutely. And the partners that have signed up for these initial units are some of the household names in this industry. So, I mean, they see the value, and we can't get them samples soon enough. So,
excellent. Excellent. I'm really happy, Mark. Do you have any words for our audience before I let you go?
No, absolutely. For more information on the software-defined power, please visit CUI.com for more information.
Excellent. Thanks a lot, Mark. I appreciate you taking the time today.
Thank you.
And I'd like to thank everybody out there in the audience for taking the time to be with us. We wouldn't be here without you. Tell your friends. This is Alix for Power Systems Design. Have a great day.